This is Daniel Crawley, Foothills Action Network. Hope you're having a great day wherever you may be. Today we are going to continue our weather school program, and we will be talking about Unit 2, which will be talking about cloud formations, and precipitation. Quickly, we'll go back and do a quick review of Unit 1, where we talked about an introduction to meteorology. We talked about what a meteorologist does, the line of work, whether it be through media, through the government at the National Weather Service or NOAA, or in research as a storm chaser or any kind of research that can go into help producing better forecasts in the future. So that was Unit 1. We talked about that. And we also talked about weather instruments such as thermometers and barometers and hygrometers and the wind vane and the anemometer, and just all kinds of good stuff here in Unit 1. Today, Unit 2, we're going to talk about clouds and precipitation. And really, this is the basis of all weather, clouds and precipitation. You can't get rain, you can't get snow or whatever unless clouds develop. And I'll go into that. We'll talk about how clouds form and then what type of precipitation there are. As always, for teachers, if you have any questions about what we talk about in our weather school programs, you can always email me at the address I have on the screen. I'll take any questions that you may have. And if at any point, maybe during the school year, if you'd like to do maybe a Zoom call or a Google Hangout, also contact me at the email address. Maybe we can set that up for you. Now, let's talk about clouds. And really, there's all kinds of different clouds. But what is a cloud made of? Well, a cloud is a collection of tiny water droplets all bunched together. They are white on the top because light reflects off the water droplets. But clouds are usually a darker color like gray or black underneath because they don't let the light shine through, and what you basically see is the shadow. So think about a cloud as it grows up into the atmosphere. The taller it gets, usually the lighter the cloud is. There's not as much water. So it has that white look to it. But at the base of the cloud, the lower part of the cloud, it's real thick and dense, and light cannot get through that cloud. So that's why it's dark. There's also, other things such as maybe clouds being way off the distance kind of give it a different color. But generally when a cloud is forming, the upper part of the cloud looks white, again because the light can go through those water droplets, and then as you get down toward the base, it's more dense, it's heavier, and it's black or darker looking colors. Now, these are different kinds of clouds, and you can look here. Basically, clouds can go anywhere from the lowest 10,000 feet of the atmosphere all the way up to 20, 30, 40,000 feet. And we'll go into those clouds right quick and talk about each one and what they may produce weather-wise. Now, look at this first one right here. You see these clouds that are in the air, they're kind of feathery, wispy. They look very thin. These are cirrus clouds. Cirrus clouds are in the highest levels of the atmosphere, 20, 30, 40,000 feet in the air. Cirrus clouds are basically ice crystals because really when you get that high into the atmosphere, it is extremely cold compared to what it is closer to the surface of the earth. So the higher up you go, the less amount of water you're going to have. But considering how cold it is, any amount of liquid is going to freeze and crystallize. And that's basically what you see with cirrus clouds. Those are basically ice crystals that are so cold they're frozen. So let's work our way down to the lower part of the atmosphere, and you can see this shot of the beach and all these fluffy cotton ball looking clouds. These are cumulus clouds, and cumulus clouds are really the building point to rain producing showers and thunderstorms. Essentially, when you have cumulus clouds, that's an indicator that there is moisture in the lower levels of the atmosphere. And when that moisture lifts, it cools and condenses in these little cotton ball looking formations. Those are cumulus clouds. They are in the lower layers of the atmosphere. Again, the cumulus clouds could eventually build to something bigger, and we'll get into that in a few minutes. Now, the image here is basically clouds that are not really at the lower levels, but they're a little bit further up, and they cover the entire sky. This is known as stratus clouds. Stratus clouds are something that you see a lot in the cold months of the year, the fall and the winter. It's like a blanket. Stratus clouds are like a blanket. They cover the sky, they usually cover the sunshine, and normally with stratus clouds, you can get rain to fall from them. So, again, the three kinds of clouds, you got cirrus, cumulus, and stratus. And the last one, going back to what I mentioned earlier, is a cumulonimbus cloud. A cumulonimbus cloud is essentially the result of a cumulus cloud growing and becoming so big that it gets up 20, 30, 40,000 feet into the air. And cumulonimbus clouds are the ones that produce big thunderstorms in the spring and summer. Cumulonimbus clouds can produce heavy rain, thunder, lightning, and even tornadoes under the right circumstances. So that is a look of the four cloud formations. Cirrus clouds, your high ice crystals. Cumulus clouds, your low-level clouds, the little cotton ball-looking clouds that form in the spring and the summer. Stratus clouds is that blanket of mid-layer clouds that you usually see during cool weather, that you usually see during rain. And the cumulonimbus clouds are the big, tall clouds that go up several thousand feet up into the air. So these clouds are going to eventually produce precipitation. And we'll go into the different types of precipitation. There's a lot of them. We have, of course, rain that we see commonly here in our area. And then we see wintry type precipitation like freezing rain, snow, and sleet. I'll go into details on the winter precip a little bit later. And you also see hail and gropple depending on the season. Now, hail is a form of precipitation that occurs when updrafts and thunderstorms carry raindrops upward into extremely cold air. The large hail freezes into balls of ice, and then they eventually fall down to the ground. So let me essentially kind of go into what's happening here when you have hail formation. When you have lift, and you got to think about this, during the spring and during the summer, during the thunderstorm season, you can get storms that produce hail. So those hailstones is basically what's happening is that water content is lifting up into the air. That air is colder, so eventually it's going to freeze into something solid, okay? Well, that hailstone eventually is going to get, and that frozen water is going to eventually get so heavy that gravity can't hold it up, so it starts to fall back to the ground. So that's how hail falls to the ground when it forms during thunderstorm season. It works its way into the atmosphere, it freezes solid, and then it falls to the ground. However, determining the size of the hail is in direct correlation to how strong a thunderstorm may be. Because what happens is when that hailstone originally starts to fall down, then there may be another updraft, upward wind motion that picks that water up again, and that frozen water, and sends it back into the atmosphere. So you start to cycle again. It's collecting more water, it's getting heavier, it's getting bigger, and then at some point, gravity is going to take back over, and it starts falling again. That whole cycle of lift, freezing the water, making it fall, only for it to lift again, determines how large hailstones get. So I figure you would definitely be interested in that. Hailstones can be generally like marble size or ping pong ball size. Then when storms get a little bit stronger, they can get up to golf ball size. And then some of the biggest storms you see, and thankfully here in North Carolina you don't see them a lot, but in some places hailstones could be as large as baseballs or softballs. And if you ever had that during a severe thunderstorm, you need to head indoors, because that can do damage not only to property such as cars or houses or whatever, it can hurt you if you're outside in it. So whenever there's a severe thunderstorm with hail, you definitely want to seek shelter indoors. Gropple. Now, gropple is an interesting phenomenon that we don't see a lot here in North Carolina, but sometimes we do in the wintertime. Basically, what happens is gropple forms when snow in the atmosphere encounters some supercooled water. And what happens is that supercooled water attaches to the snowflake and it causes it to crumble. And then it falls to the ground. So the thing you have to remember, a snowflake is essentially a crystal, and it's collecting water on the outer edges of it. That's how a snowflake forms. But if there's a lot of water involved, then there may be too much form on the outside of those crystals, and then it just crumbles and it falls to the ground. That is gropple. And one thing I always think about with gropple, you guys and gals probably think this is funny. How many of y'all like Dippin' Dots? Now, I know kids love Dippin' Dots, and me being an adult, I still have a little bit of a kid inside of me. I like Dippin' Dots too. When you go to the store next time and you buy Dippin' Dots, look at the form, the texture of those Dippin' Dots. Think of gropple when you see that next time. It's just something that's kind of crumbled. It's not in a particular shape. That is gropple. So I hope maybe that comparison, Dippin' Dots to gropple, hopefully that'll help you if that's ever a question for you during a test. Okay, winter precipitation types. And this is a huge thing for our part of the country because we see winter weather fairly common every winter here in western North Carolina. And being in our part of the country, there are so many complex details to what happens. Now, I think most of us love snow. I know most kids like snow. But it's hard to get snow to fall here in western North Carolina because different things are in play when it comes to the weather. The first thing you need to remember, and looking at this image, you need to treat the atmosphere, when you are forecasting the weather, you need to treat the atmosphere like you would a hamburger or a cake or something. It's got different layers to it. Like, for example, if you have a hamburger, you've got the bun, you've got the lettuce and tomato, you've got the meat, the cheese, and then the bun. And there's different parts to that, creation of a hamburger. Well, the same thing works with the atmosphere. There's so many different parts to it that if one thing messes up, then it prevents you from potentially having snow or whatever winter precip type. So we'll start here on the far right-hand side. Snow is what falls when the cold air is cold enough from the base of the cloud all the way down to near the ground. You need the air in that part of the atmosphere to be at or below 32 degrees. It's below freezing. And then that snowflake, like I mentioned, it's basically crystals that form. It falls to the ground, it lays on the ground, and accumulates. Now, it does snow with temperatures above freezing. That's some people may think it's what kind of myth that is, but it can snow with temperatures above freezing. If the temperature aloft is cold enough and the snow's coming down at a hard enough rate, then that snowflake can survive all the way to the ground before melting. So, if you're familiar with western North Carolina weather, some of the snows that we get here, temperatures are usually 33, 34 degrees. That is that wet, pasty-like snow that just sticks to everything. That's because the air from the base of the cloud almost to the ground is below freezing, and then just a little bit of it is not below freezing. So that snowflake is able to survive down to the ground. Now, if we look to the left here a little bit, the next precip type is sleet. And this is where the atmosphere and those different layers start to kick in. You may be at or below 32 degrees when that snowflake falls from the cloud. But, and look at this graphic right here. Let's say we have just a little bit of warm air. Let's say it's 45 degrees at 7,000 feet. and it sticks its way under that cloud. Well, what's going to happen is that snowflake is going to melt into water when it hits that area that's above freezing. But then let's say the last 7,000 feet of the atmosphere, it's back below freezing, and it freezes that water solid. Well, that's sleet. Sleet is kind of that pinging sound that you hear a lot in the wintertime when you're outside. You can hear it on the roof, you can hear it on the car, or whatever. That is sleet. That is essentially a snowflake that melts and then works its way back down to the atmosphere and freezes solid. Now, here's the thing to remember. When you melt a snowflake, you cannot recreate it. So once it's melted, it's done. You can't get a snowflake again. So depending on how cold it is, you get sleet. So let's go a little bit further to the left. Once again, you got the snowflake falling from the cloud, but then you have a little bit larger area of warm air. And let's say the sub-freezing air is just right down at the surface. Well, you can get a phenomenon called freezing rain. And essentially what happens, again, that snowflake melts. It makes its way into that warm air where it's liquid, but that other freezing layer next to the surface is so low or so shallow that it cannot freeze solid. So what happens is that rainfall just falls to the ground and it freezes on contact. It freezes on trees, it freezes on the ground, it freezes on power lines, it freezes on metal objects that are naturally colder. That's freezing rain. Freezing rain of all the winter precip types is the most dangerous. That's why a lot of times when we talk about freezing rain events, or if you hear about it on TV, it's dangerous because there's no traction. You can't walk on it. It's very dangerous to drive on it. So that's your winter precip types. You got snow, sleet, and freezing rain. And then, of course, if there's enough warm air that overrides the cold air, you just have a plain old cold rain. So that is the end of Unit 2, where we talked about clouds and precipitation types. I hope that you find this information very useful in your study of weather. And again, if you have any questions about what we talk about on our weather school program, make sure and drop me an email at the address below, and I will try to get back with you as soon as possible. Coming up next will be Unit 3, where we'll be talking about severe weather and thunderstorm formation. So stay with us, and I hope you're enjoying this weather school program.